Hello, my name is André Neves and I am here to present the work entitled Extreme Multilabel Classification Applied to the Biomedical and Multilingual Panoramas, which was developed by me, by André Lamúrias and by Francisco Couto. Our work is the result of our participation in the BioASQ 2020 tasks, namely in Task 8A and in Task MESINESP. Both tasks had a common goal, which was the indexation of biomedical abstracts with terms from an organized biomedical vocabulary. In the case of Task 8A, the abstracts were in English and it used the medical subject headings, while in the case of Task MESINESP, the abstracts were in Spanish and it used the health science descriptors. Therefore, our approach consisted in using a deep learning extreme multi-label classification algorithm which can provide the best subset of labels to index data from an extremely large label set and achieve high precision scores at the same time. Also, this approach has not yet been applied to the multilingual biomedical panorama. In addition, we decided to combine this algorithm with the named entity recognition software, with the goal of improving the label assignment by the extreme multi-label classification algorithm. We chose X-Transformer, which was previously known as X-BERT, which is the first deep learning approach to scale pre-trained language models, such as BERT, to the extreme multi-label classification. The algorithm essentially uses a three-stage framework that, in a first step, generates word vectors for each label and organizes them in clusters. Then, a transformer model is trained to classify and index each text instance to the most relevant cluster. Finally, a linear ranker is trained to rank the labels retrieved from the cluster indexes, and a confidence score is attributed to each label. As to the named entity recognition software, we decided to use MER, the minimal named entity recognition. It has a dictionary approach that, given a lexicon and an input text, it can identify the entities of the lexicon in the text, giving their exact location, additional information that might be present in the lexicon, and it is also capable of entity linking. For the BioASQ tasks, we have developed two lexicons. For task 8A, it used the mesh terms along with their synonyms, while for task MESINESP, it used the DEX terms, their synonyms, and their direct ancestors. We have developed a total of 4 models for both tasks, each developed with around 300,000 articles, so that we could also compare the performance between the English and the multilingual models. For task 8A, two X-BERT models were developed, one using BERT-based uncased and the other using CLEF, a BERT model specially designed for scientific English text. Both models were fine-tuned using the article's titles and MER was run on the abstracts. For task MESINESP, one similar X-BERT model was developed, but using BERT multilingual instead. The other model used the X-Transformer version, which was released at that time. For both tasks, our submissions were made with focus on achieving the highest micro-F score, which was the most relevant measure for the competitions, and the highest micro-precision, since extreme multi-label classification algorithms are usually focused on achieving high precision scores. For that, a threshold was used to discard each label under a certain confidence value. Taking this into account, we have developed a pipeline that in a first step processes the articles before giving them as input to X-BERT or X-Transformer. After that, the output of the algorithm is retrieved and processed, so that a file with the format required by the competition is obtained. In the competitions, our results showed low recall scores, which consequently led to lower F scores. However, we have achieved high precision values, leading to a first place in micro-precision and example-based precision measures in the final weeks of Task 8A Batch 3, and the second place in the precision measures evaluated in Task MESINESP. We then decided to compare the performance of our X-BERT models using their development sets, and we could notice that there were considerable differences between the English models and the multilingual one, with the English models achieving higher scores, especially the one developed using CLEF. In conclusion, with this work we could successfully adapt and apply a state-of-the-art deep learning extreme multi-label classification algorithm to the biomedical and multilingual biomedical panoramas, and be able to achieve high precision scores at the same time. However, our recall scores were low. This could be caused by our lexicons, which were rather simple, or by the amount of data that we have used to develop our models, and that could have affected the results. Another possible reason could be the increased focus of extreme multi-label classification algorithms in the precision measures. We could also compare the performance between the English and the multilingual biomedical models, where we noticed considerable differences, with the English models surpassing the multilingual one. In the future, we plan to develop new X-transformer models using other pre-trained models such as BioBERT, which was developed for biomedical text, or BITO, the Spanish version of BERT, in order to improve our results. We also intend to develop new lexicons to be used by MER, comprising more information such as other biomedical ontologies, with the aim of increasing our recall without decreasing our precision scores. I hope that you have liked this video, and thank you for watching.